Very well. Let's go over Trig functions a little bit and then talk about the graphs, continue talking about the graphs and their behavior. Remember that when it comes to trig function, we start dividing this up by using a right triangle. And for the right triangle, we said that, hey, suppose we have the angle theta, either given in degree or in radian. Then you have the sides of your triangle. On the right, you have x, you have y, and you have r. Remember that r is defined as square root of x squared plus y squared. Well, for this angle theta, we start defining some functions like sine theta, which defines as y divided by r. We talked about cosine function. Cosine theta is x divided by r. Then we said that, hey, if we take these two functions and do the division, we can define tangent, which is sine over cosine, or y divided by x. If we flip tangent, you're going to have cotangent. Or if you divide cosine by sine, you get cotangent of theta, which is cosine theta over sine theta, or x over y. Very good. So now we're going to just focus on the graphs and the behavior of the graphs of these functions and their behavior. Very well. So first of all, let us begin talking about our very first function, which is our sine function. Last time we talked about sine, and we showed that sine is a function that continues on both sides of x-axis. And it's a periodic function. It means that it repeats the same behavior over and over again. What was the domain of this function? What was the range of this function? False. For the domain of this function, we said that, hey, the domain is from negative infinity to positive infinity. And we represent this by r, bolded r, or parenthesis negative infinity, comma, positive infinity, and we close the parenthesis. And the range of this function, the minimum y value to maximum y value, is going to be -1 to 1 included. So the range is -1 to 1. We use bracket to show that -1 and 1, both of them are included. So this is the general domain and range of the sine function. Again, when it comes to quizzes, homeworks, exams, they might just focus on one period of this function. Sine function is a periodic function. Remember that. Sine function is a periodic function. What's the meaning of that? It means that it repeats the same behavior over and over again. The same behavior over and over again on its domain. What is the domain? The domain is negative infinity to positive infinity, or on R. So it repeats the same behavior. What is the behavior? It's the same behavior as this part. So it goes up, it reaches to its maximum it starts going down, it has x-intercept, it starts going down, it reaches to its minimum, and it starts going up, hits x-axis, intercept, then again it goes up, it reaches to its maximum, it starts going down, cutting x-axis, reaching to its minimum, and then going up, hitting x-axis, and again, and again, and again. The same on this side. It reaches to its maximum, it goes down, hits x-axis, reaches to its minimum, then goes up to hit x-axis, maximum, x-intercept, minimum, x-intercept, maximum, x-intercept, minimum, x-intercept, and so on. So it repeats the same behavior over and over again. So the period of this function, as Haley mentioned, is 2 pi. So we say that the period of this function is 2 pi. When we're talking about periodic functions, the definition is as it is. A function has period like t if f of x plus t is equal to f of x. It means that after the period t, the function repeats itself. In this case, for a sine function, the period is 2 pi. The function repeats itself after 2 pi. So you can write it this way. You can say that, hey, sine of x plus 2 pi is equal to sine of x. The function repeats itself each 2 pi period. Again, the maximum value of sine is 1. The minimum value of sine function is -1. So let's write down this important information about sine. Period of sine function is 2 pi. The maximum of sine is 1, and the minimum of sine is -1. So these are the important information that we need to know about our sine function. Let us take a look at Desmos. I want to graph different sine functions and analyze the behavior. Let's go to sine, Desmos. Suppose I want to graph sine of x. We saw this graph before. Well, as you see, the graph continues on both sides. So what if I just multiply sine by 2? So I'm changing my y values. 2 times sine x. Wow. See the waves? We have higher waves when we multiply sine by 2. What if I multiply sine by 3? 3 sine x. See, here you have the blue graph. The maximum value of 3 sine x is different from the maximum value of sine x. The maximum value of your sine is 1. The maximum value of 2 times sine is 2. The maximum value of 3 times sine is 3. The maximum value of 10 sine x is 10. Take a look at this. this. Take a look at the behavior of your graph as you multiply your graphs by whole numbers. Sine x, 2 sine x, 3 sine x, 10 sine x. Well, what if I change these to fractions? Take a look at this. A half sine x. Compare sine x with a half sine x. Take a look at this. Now you have lower waves, shorter waves. The height, the maximum value of a half sine x is a half. But if I just write it a third sine x, wow. See, the maximum value of a third sine x is now lower than a half, is a third. You can just continue this process. 1/10 sine x. This is the graph of a 10 sine x. As you can see, this graph is becoming more and more flat between 0 to 2 pi. Very good. So let us define the amplitude of sine, and eventually you're going to see it's going to be the same definition for cosine. The amplitude of y equals to a times sine of x, and later on you're going to see for the cosine as well, and y equals to a cosine x officially represents half the distance between the maximum and minimum values of the function. The amplitude is always positive, so remember to put a in absolute value sign. Very good. Let's take a look at a couple of examples. Identify the amplitude. Our very first function is y equals to a half sine x, and b, the second function, y is equal to 3 cosine x. What is the amplitude of these two functions? So, following the definition, the amplitude of y equals to a sine x and y equals to a cosine x represents half the distance between the maximum and minimum values of the function, and it's denoted by absolute value of a. If a is positive number, so you don't need any absolute value, so you write down the amplitude is a half, and for b, the amplitude is 3. Very good. Another observation that we have is, well, the maximum value for a half sine x is a half, and the minimum value is negative a half. So the maximum value for 3 cosine x is 3, and the minimum value for 3 cosine x is -3. Now let's make some changes to our x value. So first of all, you have your sine x. Now I'm going to multiply my x by 2. Wow. See the change? One more time. This is my sine x. This is my sine 2x. What if I multiply x by 3? Sine 3x. Do you see? Your graph has lower period. It's not the same as the period for sine x. What if I just change this to sine 10x? This is your graph now. Very good. So as you can see, if I multiply my sine by 2x, the period of my function becomes smaller and smaller. Now I expect you to ask, what if I multiply x by fractions, like a half? Sine x, and then sine x divided by 2. Come on. Very good. So this is my sine x divided by 2. Wow, I get a larger period. What if I divide it by 3? What if I divide it by 5? What if I divide it by 10? Oh my God. See the behavior of your new sign? So as you can see, if you change your x, you're going to change the period of the function. Not the y value, but your x behavior. Very good. So we talked about the amplitude. Now we're going to talk about period of sine and cosine function written in the form as let b be a positive number. Then the period of y equals to a times sine bx and y equals to a times cosine bx is 2 pi divided by b. So since b is a positive number, 2 pi is positive, b is positive, we do not need any absolute value here. Just the period in general is going to be 2 pi divided by b. For example, when you're thinking about sine function, for sine of x, well, you say that, hey, I don't see any b. It means that b was invisible, and this guy was originally written as 1 times x, which is just x itself. So obviously 2 pi divided by 1 is equal to 2 pi. That's why we said that the period of sine function is nothing but 2 pi. Now let's take a look at another example. B. Suppose you have y equals to sine 2x and c y is equal to sine x divided by 2. Well, this guy says, hey, my b is equal to 2. So b is 2. If I plug that into this relation, I get 2 pi divided by 2, which is pi. So the period of sine 2x is pi. We already saw that. What about this case? You have sine of x divided by 2 or sine of a half divided by x. So your b is equal to a half. So you get 2 pi divided by b. b is a half, which gives you 2 times 2, 4 pi. These are the periods of these three functions.